Has this ever happened to you before, where you've had a trig identity in front of you and you've been working on it for the longest time that you're like, you know what, nope, this is impossible. This is not a trig identity. You could be right. Because the thing is, sometimes equations look like trig identities, but they're actually not. And in advanced functions, we're going to have to decipher which ones are identities and which ones aren't. Now, the way that we do that is we provide some sort of a counterexample. So a counterexample is where you give an example of a value of x, doesn't matter, just one value of x, any value. And if you plug that into your left side and into your right side and they don't balance, then you know that you have a counterexample and it's not an identity. So what value do you choose in order to sub into the left side and the right side? You can choose any value you want, but let's just say you're not allowed to use a calculator. Then the special angles are probably the ones that are the best ones to use. So 30 degrees, 45 degrees, and 60 degrees, or I guess 90 degrees, 180 degrees, you know, any of the normal ones, any of the ones that you see a lot of times. Or I guess now we have to talk in radians since it's advanced functions. So pi over 6, pi over 4, pi over 3, and so on. All right, so let me show you how this works. This is example number 2 because it's a continuation of the last 4.5 video, and we just want to prove that this is not an identity. In other words, why don't we sub in values of x and y, and we just want to make sure the left side does not equal the right side. Okay, now I did this example in another video before, and again, I'm just going to explain. A lot of people think that you can just sub, or I guess distribute sign into the bracket to get something like this. You're not allowed to do that because there's no multiplication symbol here. Sine is of this entire thing. This is the angle bracket. Okay, but let's just prove that. I'm going to arbitrarily pick two numbers that I want for my x and my y. So here we go. We'll just pretend that x is pi over 4 and y is pi over 6. I'm going to sub those numbers into the left side and the right side, and we're going to prove that they're not equal. Okay, so let's work on the left side first. Sine of my x plus my y. Now, what you could do is, if you had a calculator, just add these guys together, take the sine of it, and get your answer. On a test, I would assume that your teacher would not want that because it shows that you have no idea about any of your trig formulas. It doesn't show that you actually know anything other than the fact that your calculator, you can punch the buttons in. So why don't you use some of the compound formulas instead? This is an addition sine compound formula. So what I'm going to do is I'm going to use that formula. Sine x plus y is equal to sine x cos y plus cos x sine y. Now what you're going to do is you're going to evaluate each of those ratios. So I would use a quadrant table in order to figure out what this equals to and what this equals to and so on. So I get something like this. I'll go through the entire solution with you. Alright, so I got sine pi over 4 is equal to 1 over root 2. Cos pi over 6 is equal to root 3 over 2. There's my plus. And then this is the answer for this one, and that's the answer for this one. Then we're going to do a little bit of BEDMAS, multiply these guys together, multiply these guys together, and get this fraction and this fraction. Then I'm going to add them. Well, it's good that I have the same denominator. So I'm going to have the same denominator. I'm going to add the numerators. Now you don't want any roots on the bottom. That means that we're going to rationalize. Okay, and we get something like this. The root of 4 is going to be 2. And then this is our final answer. Okay, so what I'm going to do is the exact same thing for the right side. And notice that your x and your y, when I sub them in, I actually get an answer of this, which didn't match the other side. Therefore, my left side does not equal to my right side, and I can say that this is a counterexample for the trig, I guess you can't really say identity, so it's trig equation. Okay, so here's another example, and again, I'm just going to pick a random number that I want for my theta. So I just said, let theta equal pi over 4, some special angle, okay, any one that you want. Now I decided on pi over 4 because I wanted these 4's to cancel out. So when I have 4 pi over 4, these guys are going to cancel out, and I'm just going to have pi by itself. I guess it didn't really cancel out here, but oh well, what can you do? Okay, now the next step is to figure out what all of them equal to. So I'm going to probably have to figure out my quadrants, and I drew some of them right down here. So to figure out cos pi, I drew, now this is a little bit tricky for some people. Pi actually goes to the branch. Now to draw the triangles for the branches, I mean, you basically have to think of a unit circle. So this is 1, but since the triangle does not actually exist because it's collapsed along this branch, it's going to have a height of 0. Okay, so basically my cos is going to be my adjacent, -1, divided by 1. So I got that right there. If that's difficult to understand, I mean, again, you can use your calculator. Just punch in cos pi and you'll get -1. If you're not allowed to have your calculator, probably with the value of pi, it might actually be easier to think of the cos graph. And when you have cos of an x value of pi, it equals to -1. Okay, so I just did the quadrants for the other two, and those are my two answers. Okay, now I'm going to put these guys together and hope that they are not equal to the right side. Okay, so rationalize the denominators, and then I get something like this when I put everything together. So notice that the left side does not look anything like my right side, and therefore we can actually say left side does not equal right side. Okay, so again, basically everything is a trig identity, unless of course you can sub in a number and prove that it is a counterexample, which means that it is not an identity. Now usually on a test, I would assume that the teacher might say prove that it is not an identity or prove that it is an identity. Although I guess if you have your calculator, you can do a quick sub in. Take pi over 4 and sub it into all your x's or your variables and just prove really quickly whether it balances or it doesn't. Okay, so I hope this is very helpful. Again, if you need any background to trig identities, try to check out my other videos on any of the basic skills from grade 11.